Okay, so graph the following, write A and B using interval notation, write C and D using set builder notation. And what we have here is unions and intersections of sets. And the difference between a union and an intersection, if I don't know if I've ever described this to you guys from other classes, but a union of sets means that if it belongs to either set, it needs to be graphed. An intersection has to belong to both sets to be graphed. For example, let me give you an example. Let's have the sets 1, 2, 3, and 2, 3, 4. Okay. If we're looking at that as a union, the union of the sets would be the set 1, 2, 3, 4, because that's all the numbers from both sets. Where the intersection would simply be 2, 3, because that's the only numbers that belong to both sets. So when you're looking at these two symbols, union or intersection, that's how you decide what you're graphing. So for the union, I want to graph this and this on the same number line. For an intersection, I want to find out where those two graphs would overlap and only graph that part. Okay? And C and D we'll get to in a minute. So if we take a look at A, we want set, but for our interval notation from our set builder, let's take a look at this part first. Okay? And it's all the numbers less than or equal to -1. So starting at -1, going all the way to negative infinity. It has an equals to, so we want to include -1. So if I begin by just putting my interval from where I'm going to, and where I'm going to. And then again, I make the decision of parentheses or bracket. Infinity always gets a parentheses. And the only time you get a bracket is if there's an equals to, which there is, so I'm going to put a bracket at -1. Then the union symbol happens, I do that. It's just a U without the monkey tail. And then x greater than or equal to 2 starts at 2, greater than goes to the right. So again, if I just write my interval to begin with, 2 to infinity, and then I make a decision about parentheses and bracket. This says greater than or equal to 2, so we're including 2, so we put a bracket at 2. We never include infinity, so we put parentheses there. That's the interval notation for the same problem. And if I want to graph that, union means to graph both inequalities on the same number line. So I want to graph all the way from negative infinity, which lives all the way down here, up to -1 including. So I'm going to put a closed circle at -1 and shade off to the left towards negative infinity. Make the arrow bold. You don't have to write the infinity there if you don't want to. I just put it there for effect while I'm teaching. The arrow just denotes that it's going on to negative infinity. And then 2 bracket. So we put a closed circle at 2. We're going up to infinity, which lives over here. So we're going to shade all the way off to the right and make that arrow bold. Show that it goes on forever in that direction. Okay. Looking at B, first of all, going interval notation, let's go Kalen. Well, actually, that's not the same one. Kalen, go ahead and tell me what I should write here.
The interval notation?
For this one.
It'll be infinity.
Actually, negative infinity.
Or negative infinity,
Okay.
yeah, because it's negative.
Yeah.
And then the -1.
All right, and what kind of?
And then parentheses by negative infinity, and then brackets.
Bracket on 1. And then I draw the intersection symbol because that's what we're doing. And then PJ, what about the other one here, this one?
You would have less than 5. No, it's not. Yeah, it is. So you'd have negative infinity,
Negative infinity?
5, and then they're both parentheses.
Both parentheses. And this one's not right, is it? This purple one? What's wrong with the purple one? Now that I look at it.
It's everything greater than 1. So it's
Greater than or equal to -1, so we'd actually start at -1, go this way, so we should have actually written it, we wrote it backwards here, so
Infinity.
we're going to go from -1 to positive infinity, and then we're still going to bracket the -1, still going to parentheses infinity. All right? Whenever you do interval notation, always start from the smallest number, go to the biggest number, always go left to right, order like that. But yeah, that's how it should be, because greater than or equal to starts at -1, gets bigger. All right, now what we're looking for is an overlap. Okay, where these things would overlap. So if we think about the purple one, it's going to start here and go that way, right? If we look at the red one, it's going to start at 5 and go that way. So we're looking at an overlapping situation here. The overlap will happen between -1 and 5, right? But notice that at -1 we're going to have a closed circle, at 5 we're going to have an open circle. So 5 belongs to the purple set but not to the red set. So we still have to put open and closed circles properly. So I'm going to put a closed circle at -1 because it's included in both sets. Open circle at 5 because it only belongs to the purple one, not the red one. And then we're going to shade in between because that's the part that where they overlap at. So the intersection would just be those. If there's no overlap at all, it's an empty set. So there's no number line, I mean the number line would be empty. Typically they'll do some overlap. If you only overlap at a single number, that's the number. So let's say this said x is greater than or equal to -1, this says x is less than or equal to -1. -1, so you just graph -1. If this just said less than -1, then it would still be an empty set because everything up to -1 is included there, -1 is included there, so there's no intersection. But as far as the union is concerned, they'd both be graphed, then the entire number line gets graphed in that scenario. So just keep that in mind that with intersections, very exclusive, unions are very inclusive, so you're going to get bigger graphs on unions. Moving on to C and D, these start off in interval notation. They want us to move on to set builder notation and then also graph them. Again, for my purposes, I find it easier to graph while it's in the interval notation, so I might graph first, then go to set builder off of it. This, notice, is a union of sets, so we're going to go from -infinity up to 0, not including 0, so that gives me an open circle at 0. -infinity lives all the way down here, so we're going to go all the way off to -infinity. And again, it's very descriptive of what you're graphing. So start here, end here, start here, end here, open circle at 0 because of the parentheses. And the second one says bracket 1 to bracket 3, so that means we start at 1, we end at 3, both bracketed, so they're both closed circles. And we shade everything in between because again, we're dealing with real numbers unless otherwise instructed. Okay, looking at that, and again, I need to write a set builder notation to represent it. Okay, we start off with a set bracket. We call the letter what we're going to use. I use X every time. It doesn't matter what letter you use, but I like horizontal lines to be X, just to be in the habit of horizontal lines, the X-axis kind of thing. Okay, if I'm describing this, this is everything less than 0, so X is less than 0. So that represents the blue part of the graph. And I'm going to union that with the green part of the graph, which is going to be the set of X such that. Now when you start at a regular number, end at a regular number, you're going to do a compound inequality, a conjunction. You write your smallest number less than or equal to X, less than or equal to the biggest number. That right-hand set bracket should be easier to draw. Look like my 3. When you do a compound inequality conjunction like that, always go with less thans. Smallest number, less than the letter you're going to use, less than the biggest number, and then again equals if necessary. So since they're both bracketed, they're both closed circles, they're both equals. If one of these was an open, so if that was a parentheses, this should just say less than 3. So again, creating set builder notation out of this picture, that's how you do it. And finally, D, similar problem. This one has both finite, or they're still infinite because of real numbers, but they're finite starting and ending points. If we look at -1 up to 3, intersected with 1 to 5. Okay, so let me just show you another idea of intersection that you might like this way. So we'll see. If not, do it however you want to do it. The ending graph would be where they overlap. All right. But if I were just to try and graph -1 to 3, that's a closed circle at -1, a closed circle at 3, shade between. And if I graph from 1 to 5, that's going to be a open circle at 1, an open circle at 5, shade in between. Okay. As far as overlapping is concerned, looking at the blue graph is everything that's blue, the green's everything that's green. They share this part here. The part that's iffy is what kind of circle should I use at 1 and 3. All right, so again, understanding what these things mean, an open circle means that 1 is not part of the green graph, but it is part of the blue graph. It has to be part of both graphs to be the overlap. All right, so again, if you get a visual of this, this only belongs to 1, this dot belongs to both. And sometimes people get thrown off because there's an open circle here at 5. They think that 3 should be opened also, but again, the only thing open are 1 and 5. Everything between 1 and 5 is being graphed there. So as far as the beginning point, 1 open circle, 3 closed circle, that's the overlapping part. So if you did that and then you just drew the actual answer, let's see, open circle at 1, closed circle at 3, shade in between. There's my intersection of the two sets. Again, if you can visually represent that in your mind to create this green graph at the bottom, great. But if you have to actually see an overlap to process what's going on, do it that way. Do 2 number lines, maybe even scratch the paper if you just want your final answer to be there. But however you want to do it is fine. As far as set builder notation is concerned, what would the first one look like, Caitlin?
It'd be brackets, and you have the x, and then the line, and then negative 1 less than x is less than 3. Wait, let me see. That's for the left one.
Anything else?
Maybe equals to.
Yeah, very good. Equals to on both of them because of the brackets. Brackets mean we include. Okay, that's an intersection, so we do the upside down view without the monkey tail. And then what about the green one, PJ?
You'd have bracket x in your vertical line, and you'd have 1 is less than x is less than 5 in bracket.
That's it. So there's a couple problems like that too. Whatever it starts off in, if it's an interval notation, go to set builder and vice versa. Graph the correct number line. That's what I'm looking for on that problem, those 2 problems on the homework.